Hello all, welcome to Year 11 Chemistry and the Introduction to Quantitative Chemistry topic. This is video number 4 and I'm going to start the discussion around stoichiometry because this is one of these really important chemistry words. In order to set the context, I want to start putting in some of these little inquiry-based questions, something that just helps focus your attention on what the purpose of the video is. So in this particular video, we're looking at what is the benefit of writing balanced chemical equations. One of the most important things we have to do in chemistry is to write balanced chemical equations. And that is going to be very useful, particularly in this topic, as we do lots of calculations around masses, volumes of gases, and concentrations of solutions. And if we're going to do that, then the first and the most important thing we need to do is to make sure that our chemical equations are balanced. That gives us one very, very important ratio, which I'll talk about at the end of this video, but it also starts us on a process of understanding that balanced chemical equations actually allow us to do very important mathematical things. Now, you may not have chosen chemistry because you were expecting to do very important mathematical things, but nevertheless, mass is a very important application in chemistry, or at least it has very important applications in chemistry. And so therefore, what we need to do is to blend our understanding of the law of conservation of mass, which is something that we previously talked about, and our understanding of how to balance equations to ensure that we are always following this particular law. In any chemical equation, we have reactants and products. So one of the chemical reactions, for example, that we may want to look at is magnesium burning in the presence of oxygen gas to form magnesium oxide. Now, this is the way that each of these substances would look. Magnesium is a solid, so we write it as just its empirical form, which is the simplest form that we can write it in. We know that there's not just one magnesium atom, but we know that the simplest way we can write that is just as a single magnesium. The S indicates that it's a solid. Oxygen is actually in the atmosphere, it's in the air, and so when the magnesium combusts, it is combined with O2. That is the standard form for oxygen. It's a diatomic element and therefore exists as two atoms, and so it's also a gaseous form, so that's its subscript is a G for gas, and it's in its O2 form. When we form the compound, we find magnesium is in the second group and oxygen is in the 6th or the 16th group, and therefore magnesium has a +2 charge in terms of its valency and oxygen -2. Now this means there's a ratio of 1 to 1 for us to form the compound. So here are all of the components of this chemical reaction, all in front of you, all in their standard forms. But this equation is not balanced. There is one magnesium, but there are two oxygens here, and only one of each magnesium and oxygen over here. Once we've written the form, and it's very, very important that you do this first, make sure that you've got your compounds right, then you can start balancing by putting coefficients at the front of each of these. So in this case, because we have two oxygens, and I'll just pop a different color here, we're going to put a 2 in front of the MgO. Now that 2 there means there's two oxygens, but it also means there's two magnesiums, which means I also have to put 2 in front of the magnesiums at the front. This means I have 2 Mg to 1 O2, and that gives me 2 MgO. There's a little sort of sequence which you might find useful. A lot of it is trial and error. So you want to count the number of each elements in the reactants and the products, use coefficients and place them in front of the compounds or elements as needed, and where possible, leave an element till last, as any coefficient placed in front of an element only affects that element, such as in lithium or in the magnesium in the example that I've talked through, whereas any coefficient placed in front of a compound like MgO actually multiplies all of those atoms in the compound. So 2 in front of NaCl means 2 sodiums and 2 chlorines. So therefore leaving the elements to last makes it a little bit easier. But why does this matter? Well, the reason that it matters is going to be explored in much more detail in future videos, but the most important thing to understand is the importance of ratios. Once we get our balanced equation, we do two things. Number one, we ensure mass is conserved because we haven't created any new atoms or lost any old atoms. But also the ratio. Here I have another equation, magnesium plus hydrochloric acid forming hydrogen gas and magnesium chloride. The ratios here are the critical things, 1 to 2 to 1 to 1. Now this is going to be very important as we explore a very important concept called the mole concept, which will come up in the next couple of videos. But I just introduce it here so you get an understanding of why it's important that we start playing around with numbers as part of stoichiometry. Thanks for watching.